You ever look at something in nature and think, wow, Mother Nature is so cool for creating such random, beautiful landscapes? Okay, actually, in that instance, you'd be wrong. There is order in that seemingly unpredictable chaos. And that order comes from these patterns called fractals.
Here's a fractal. What makes them fractals is as you zoom into the infinite perimeter, it looks the same as where you started. That's self-similarity for ya! They derive from mathematical equations as an ongoing feedback loop, or recursion, where the pattern takes the input and returns the output, which becomes the next input, and so on. Here's the equation to make this huge set. Yeah, it's that simple. So C is a complex number, which means that when graphing this set, C is a mixture of a value on an imaginary axis and a regular number axis. Basically, you pick a C value, let's say 1. Plug that into the equation. Zn is going to be 0 since it's the starting iteration, making 1. Then you plug that 1 into the next iteration, making 1 plus 1 equal to 2. Plug that into the next iteration, 4 plus 1 is 5. Plug it in again, you get the point. If the values blow up to infinity, it's not in the fractal. Since this value of C does that, it's outside of the set. However, if C makes the numbers stay less than or equal to 2, it'll be in the set. The reason why fractals are so special isn't just because they look cool, it's because they defy geometry as we know it. We have 1D, 2D, and 3D, right? Well, with fractals, we have 1.26 or 2.73D, which is called fractal dimension. Let me break this down. A line is one-dimensional, so when scaling it by a factor of 2, its length increases to 2. Mathematically, 2 to the first power, or its dimension of 1, is 2. Now let's take a two-dimensional square. Scaling that by 2, its number of squares increases to 4, because 2 to its dimension 2 is 4. Same thing with a cube. If we take 2 to its dimension 3, we get 8, the number of cubes. And it's the exact same thing with fractals. Let's take the Sierpinski triangle. If we scale that by a factor of 2, there's now 3 triangles. So to get its dimension, solve for 2 to dimension equals 3, and we get 1.585. Okay, so it's a cool shape, and it has to be quirky by having some decimals as a dimension. So why can't we just sweep it under the rug? Well, it's the reason we're alive. No, but really, our lungs are made of fractals. Scientists can actually use the fractal dimension of lungs to see if someone has cancer. And remember about why nature isn't completely random? They're in these tree branches.
Go outside. What can you discover?